let's see the most complicated derivatives that we could possibly see in this entire course. What we want to look at here, first off, I don't like square roots. I don't like taking their derivatives, so let me first rewrite this. I'm going to rewrite this part as 2x cubed minus 1 to the 1/2 power. As I look at this, I should be seeing what am I dealing with? Well, I have two things that are being multiplied by each other, so I should be using the product rule here. So this is what I'm going to do. My product rule is the first times derivative of the second. So I'm going to just write it like this, and you'll see why in a minute. The derivative d dx of this function, of this 2x cubed minus 1 to the 1/2 power. So it's first times derivative of the second plus the second to the 1/2 times the derivative of the first, which again I'll just write real quick as d dx of x squared. Now why did I do that? Well, as you can probably tell, this guy right here is not a common derivative. That part right there, I'm going to have to use the chain rule because I have an inside and an outside part. So this is how that's going to happen. I'm going to write everything else I can. So I have x squared times, now derivative of this guy is going to be the derivative of the outside, so bring the 1/2 in front, with respect to the inside. So now this is going to be to the negative 1/2 power, times the derivative of the inside, which would be 6x squared. Now this part over here, I can just do this derivative here normally. I don't have any issue with that. So the first, I'm just going to keep it the exact same, or that should be the second, I should say. And then the derivative of x squared is just 2x. From here, it's just, can I simplify anything? Well, in this first part, I have a 6 and a 1/2, so that can combine to be 3. I have x squared times x squared, which would give me x to the 4th. And everything else can just be written as is, to the negative 1/2 power here, and then plus. Either way, it doesn't matter how it's written, 2x cubed minus 1 to the 1/2 times 2x. So when you're doing these problems, if it helps, write out this, I'm taking the first times the derivative of the second. Write it actually out like that to start with. Eventually, you should be able to skip this first step in yellow and go straight to that blue step. But that could take a little bit of time just because there's lots that are going on. Alright, here's another example. That was using product rule with a chain rule. Here's one that you would use the quotient rule with the chain rule. And here's what it would look like. So quotient rule is low d high, so we write the low, times the derivative of the top, which is just 1, minus high d low. So there's your up high function. Derivative of the bottom. Well, the derivative of that whole big thing is going to be another chain rule. So derivative of the bottom would be 3, because you bring the 3 in front, x squared minus 4x, because it's with respect to the inside, lower the exponent by 1, and then that's times derivative of the inside, which is 2x minus 4. From here, it's just, can I simplify this at all? Well, not yet, because that's all over, I'm sorry, low squared. So that'd be x squared minus 4x. It was to the 3rd power. When I square it, it becomes the 6th power. Now I can try to simplify it. I would leave this part just as it is, x squared minus 4x cubed times 1 doesn't do anything to it. Minus, I would take this x and 3, call it 3x, and distribute it into a linear part here. So it would be minus the entire big thing. It would be minus 6x squared minus 12x times that x squared minus 4x squared. And then again, all that is over the x squared minus 4x to the 6th power. And what I could do, if I wanted to, I could make this positive and change the signs in here, but there's not much really I can do beyond that. At this point, if it's a multiple choice, you need to try to match up and say, well, what do they have in common? Now here's the one thing they will do. Notice, every factor that you have here has an x squared minus 4x somewhere. So what I would try to do is see if I can simplify that at all, which I definitely can. The most that they have, or I should say the least that occur here, are the 2. Well, I can get rid of 2 here. That means I can get rid of 2 here and 2 there. So I could rewrite this in the end, x squared minus 4x, and then I'd still have, from this part, the minus 6x squared plus 12x all over x squared minus 4x all to the fourth power. And I even have some common factors here then. So I would have a negative 5x squared, I would have a plus 8x, and I would on the bottom have the x squared minus 4x all to the fourth power. If you can get to this step, I'm very happy, but we definitely need to be able to simplify that even more if you see those common factors that we can go and cancel out. All right, let's continue on to see another one, the toughest ones, the ones you will hate the most. What's going to happen here? We have an outside and an inside function. The outside function tells me that I'm going to have to do a chain rule. So let's try to break this down. So derivative of the outside, meaning I'm bringing the 2 in front with respect to the inside. So I keep the inside the same. My exponent would now be 1, so I can just leave it just like that. Then times derivative of the inside. Well, what's the derivative of this guy? The derivative of this guy, I'm going to try to do in another color so you can see it, is going to be, well, it's a quotient. So quotient rule. So with that one, it's low d high. So there's low times derivative of the top minus high times d low. Well, derivative of that is 2x all over low squared. So it would be x squared plus 3, the quantity, squared. So now the tough part is, can I simplify this at all? Well, yeah, I really can. I would first distribute that 2 through, and that would give me 6x minus 2 up top. I'm going to keep everything else the same. And then times this whole thing again. So x squared plus 3. Actually, even more. Let's undo those. What I can do here, I can distribute that 3 through. So this would be 3x squared plus 9. And then I'd have, when I do this, I'd have a minus 6x squared and a plus 2x when I distribute this, distribute first these guys through and then distribute the negative. And again, over x squared plus 3, that quantity squared. Keep simplifying. 6x minus 2 up top, x squared plus 3 still on the bottom here. This can simplify to be negative 3x squared plus 2x plus 9 all over this x squared plus 3, the quantity squared. And my last step, since I'm multiplying, I should be able to multiply these fractions. So I'm just going to leave it in factored form because I know you can FOIL if need be. So I leave my numerator the exact same. And then at the bottom, I have an x plus 3, or an x squared plus 3 to the first and to the second. That means when I multiply them, I add my exponents. And I should get that now to the third power. And I would leave it just like that. Again, if you need to, you should be able to simplify this inside if we needed to try to cancel things out. There you have it. Some of the ugliest looking chain rule problems. This would probably be one of the ugliest problems you could ever see in terms of doing a problem. Now the only other kind that cause issues is if you have to do the chain rule multiple times. And what I mean by that is this one right here. If I do my derivative, f prime of x, derivative of the outside. Well, first, sine cubed of something means that I'm doing sine of this whole thing, sine of 4x, that whole thing being cubed. All right? So if I do that, derivative of the outside means I would bring that 3 in front with respect to the inside, meaning I keep the inside the same. Keep that inside the same. I lower the exponent by 1 times the derivative of the inside. Well, now I'm looking just at this part and taking its derivative. Well, this also has its own outside and inside. So when I do that part, to look at that, the derivative of the outside of this guy is cosine with respect to the inside times the derivative of the inside, which is 4. So there's lots of things going on here. So when I simplify this, I'm going to get the 4 times 3 gives you 12. I'm going to have a sine of 4x, that whole thing squared, and then times cosine of 4x. And again, if you use parentheses around the 4x, that's cool. If you decide not to, that's fine as well. And then we can rewrite it just in the proper trig function term, putting the squared with the sine. You can do that as well, and this gives you sine squared of 4x times cosine of 4x. All right, I want to go through that one again to make sure we got this all down packed. This is one of the trickiest ones there is. So it's derivative of the outside. I bring the 3 down in front I keep the inside part the exact same, so sine of 4x, and I have to lower the exponent by 1. And now I need to do derivative of the inside. Here is your inside. So, but what I notice here is I have another own outside and inside for that part right there. So when I do that, the derivative of this whole guy is like saying I'm starting over. Sine of 4x, what's an outside and what's the inside? So the outside is sine. Its derivative is cosine. I keep the inside the exact same. And then I multiply by the derivative of the inside, which is 4. And then from there, it's just simplifying. The 4 times 12, excuse me, the 4 times 12 will give you, not 4 times 12, 4 times 3 gives you 12. I'm going to have sine squared of 4x, and I'm going to have a cosine of 4x. So make sure we can do these. Chain rule within chain rule is probably the toughest kind that you have to deal with. That, or maybe this last one where you have to do a chain rule within a quotient rule within a chain rule. Lots of things happening. Just break it down, take your time, and the more you do these, the better off you're going to be. So please keep practicing as much as you can.